Hi, Mrs. Greathouse here. We're working on Chapter 12, Section 2, Chemical Calculations. We're really getting into the guts of stoichiometry now. When an airbag goes off in a car to protect the driver or the passenger, the chemical reaction that happens is a particular combination of amounts of the compounds that are going to make that reaction happen. This has to be calculated with stoichiometry in order for this reaction to be a success. It has to be in the proper proportions. Okay, to calculate this proper proportion, we use what we call a mole ratio. Mole ratios give us that correct proportion between reactants and products, or between moles of reactants or moles of products. We simply use this mole ratio as a conversion factor. To set up the ratio, we will use known moles of A, or one reactant, divided by the moles of A that were given. Okay, I'm going to set that equal to the known moles of B, our other reactant or maybe a product, divided by X, or our unknown moles of B. For the knowns, we always use the coefficients in our balanced equation. We have to remember that to determine our mole ratio, we use the coefficients in the balanced equation to find our moles. Or if we are given grams, we can divide by molar mass to calculate our moles. Okay, this young lady in the photo is massing out a certain compound. She knows how many grams that she needs so that she can set up the proper mole ratio to have the reaction she needs work properly. So here's our practice problem. How many moles of ammonia are produced when 0.6 moles of nitrogen react with hydrogen? We have a balanced equation here. This is the coefficients tell us our moles. We need to set up a mole ratio to solve this problem. Okay, so our mole ratio is our known of A divided by what we're given of A equal to the known of our B divided by our unknown of our B, which is going to be our X. Okay, so what we know and what we're given is this 0.6 moles of nitrogen. Okay, for both of our knowns, we're going to take that from our balanced chemical equation. Okay, our nitrogen becomes our A, and our our ammonia is our unknown, that's our B. So I'm going to make a mole ratio on the left side with what concerns nitrogen, and ammonia on the right side. What I know about nitrogen from my balanced chemical equation is that its coefficient is 1. Okay, so that goes in the first part of my ratio. What I know about ammonia from my balanced chemical equation is that it will, if we have 1 mole of nitrogen, 3 moles of hydrogen, we will make 2 moles of the ammonia. So what I'm given then, given of A, given of nitrogen, is this 0.6. So that goes on the bottom part of my nitrogen ratio, and I need to find out how many moles of ammonia. That's my unknown. So that goes there as an X to solve. If I multiply across 6.6 times 2, divide it by 1, okay, X equals 1.2 moles of ammonia. It's very important that you keep everything labeled and organized in your work. In the last sample problem, we went moles to moles. We can go mass to mass. What we need to remember is moles equals grams over molar mass. And these are the steps that we'll follow. First of all, make sure your equation is balanced. Then convert your mass to moles. Use that moles to set up your mole ratio. Solve for X to find the number of moles. Then we can convert moles to mass, or if our question asks for it, we can convert those moles to representative particles or even volume. So let's try a mass to mass stoichiometry problem. Okay, calculate the number of grams of ammonia produced by the reactions of 5.4 grams of hydrogen with an excess of nitrogen, and it gives us our balanced equation. When I start out these problems, I always write out what I'm looking for and what I have. We know that we have of hydrogen, we have 5.4 grams, and I need to solve for my grams of ammonia, and I put a question mark by that. Okay, I need to find how many moles of hydrogen gas I have so I can make a mole ratio. So moles equals grams over molar mass. So that's going to be 5.4 divided by 2. My molar mass of hydrogen gas is 2, which gives me 2.7 moles of hydrogen gas. Now that I have moles, I can set up my mole ratio. First, for my knowns, what goes on top, I take that from my balanced chemical equation. My hydrogen coefficient is 3, ammonia coefficient is 2. Those go on the top. I know I have 2.7 moles of hydrogen gas, so that goes in what I've given, and my moles of ammonia gas is what I need to find out. When I multiply across and divide by 3, I find that I have 1.8 moles of ammonia. Okay, I'll pause so you can finish writing that. Then I need to clear my screen so I can continue on. Okay, so with my 1.8 moles of NH3, to completely answer my question, I have to find grams of ammonia. So I know that moles equals grams over molar mass. So I'm going to plug this moles into there. 1.8 equals grams over the molar mass of ammonia is 17. So 1.8 times 17 is 30.6, and that's my grams of ammonia. Okay, that's your first stoichiometry problem in a nutshell. not so bad, several steps, but just like when we did our mole conversions, remember it's moles in the middle. Always go to moles. So review your mole formula. We'll do some more examples in class tomorrow. Thanks.